All right, so polyatomic ions are like monoatomic ions in that they both have either positive or negative charges. Now we said when we're looking at monoatomic ions, when we look at ionic bonding, what we did was we would do something, let me look at something really simple here, like maybe lithium. So here's the orbital notation for lithium. All right, and let's do fluorine, just to make something really simple here and real fast. Okay, and when we're doing ionic bonding, what we said was that lithium can get to a valence level that's full by getting rid of one electron. Okay, so what we can do then, I put an extra electron over there. There's not supposed to be one there. Oh, there it is. At least not initially, there's not supposed to be an extra electron there. All right. So what we did was we can move this electron here down into that empty slot. And we did that with a lot more complex things when we started. And the result then is we get lithium that has just that 1s sublevel. But since we got rid of an electron, what happened to the lithium? What did we change? 1 plus, okay? And the fluorine over here then, we're putting an extra electron on it. This is where I put that extra electron back in there I started with a while ago. And when I've got an extra electron in there, what happens to this? Negative, okay? So those are monoatomic ions, okay? Single atoms that either lose or gain electrons. Monoatomic ions. Mm-hmm. Okay. All right. And then after we looked at these, this ionic bonding, we also looked at covalent bonding. And covalent bonding was sharing electrons. Okay? Polyatomic ions are kind of a combination of both these ideas. Polyatomic ions are covalently bonded atoms with an unequal number of protons and electrons. Okay, so in an introduction to this, I want to introduce you to what is called the autoionization of water. Okay, autoionization. The prefix auto means something that happens automatically. Okay? Ionization means we're making a charge. Does that make sense? If ions have a charge, ionization means making something that has a charge. So let's look at the Lewis dot formula for water. We did this yesterday when we're doing tetrahedral electron pair shapes and then finding the molecular shapes from that. This is a Lewis dot formula for water. Okay? I'm sorry. Now, in water, there's a very, very, very small number of these water molecules. So water out of the tap, put in a cup, a very, very, very small number of these water molecules break up into ions. And what happens is the hydrogen breaks away. The hydrogen breaks away. But let's go back just a little bit and remember how we put that water together when we did our Lewis dot formula. We had an oxygen that had 6 electrons and hydrogen that had 1, and we shared electrons to get to that Lewis dot formula. All right? Okay? So hydrogen brought an electron here, hydrogen brought an electron here, and they shared these electrons to get to that water Lewis dot formula. When the hydrogen leaves up here, when this autoionization of water occurs, the hydrogen leaves, but it doesn't take its electron with it. It leaves behind its electron. Okay? Well, if we take an electron away from hydrogen, what do we have? What is hydrogen made up of? Hydrogen is made of 1 proton and 1 electron. Most of them are anyway. We did it in the last unit. We looked at how we build atoms. Remember how we did nuclear equations and things? Most hydrogens have 1 electron and 1 proton. If hydrogen leaves without its electron, what's left? What? Well, no, there's something left. If hydrogen is made of 1 proton and 1 electron, but it leaves without its electron, what's left? A proton. That's all it is. So this hydrogen leaves, and when it leaves then, we got a hydrogen ion that essentially, for all practical purposes, is a proton. Okay? Well, that's really something for a later unit. Okay? Has to do with something called electronegativity, which we did talk about in the last unit, but we haven't really gotten into how it works practically, in a practical sense. All right, well, if the hydrogen leaves, what remains then is this. Remember, hydrogen left without its electron. Okay? So this structure that remains has an extra electron on it. Does that make sense? Hydrogen left. It left behind the electron it originally shared. So this structure has 1 more electron than all the protons in that structure. So what do we need for this symbol here then to make it complete? It's got an extra electron. It needs to be negative. So this whole structure then has a negative charge. Okay? This then is a covalently bonded set of atoms with an unequal number of protons and electrons. This is a polyatomic ion. It's an covalently bonded. We're sharing 2 electrons right here. The number of protons and electrons are not equal. We have more electrons than protons, so it has a negative charge. This is an example of a polyatomic ion. And it has a special name. It's called hydroxide. And the name of this is hydroxide. And it's an example of a polyatomic ion. Okay. This hydrogen ion is a proton because it originally had just 1 electron. Hydrogen's made of 1 proton, 1 electron. If it leaves behind its electron, what's left is a proton. And it's an example of a monoatomic ion. Okay? An example of a monoatomic ion. Everybody got that? Let's look at one more. All right. So we looked at water and how it autoionizes. Let's see. Let's stop this one.